All right, I'm back for one more night. I know said I was calling it quits for tonight, but it looked fun, so I wanted to take care of it. Um, Question 7: the signal y of t is equal to x1 of t times x2 of t is sampled by a periodic impulse train. It is known that x1 of t is band limited to 500 pi and x2 of t is band limited to 1000 pi. What is the Nyquist rate of signal y of t? So the Nyquist rate is the minimum. The Nyquist rate is the min sampling frequency needed in order to prevent aliasing, which we know from the Nyquist theorem is we'll call omega I is equal to 2 times omega m, where omega m is the maximum frequency content of the signal. Now, we don't know what x1 looks like, we don't know what x2 looks like, but we know what it's band limited to. So I just drew two arbitrary shapes here pretty much. Um, but so y of t is equal to x1 of t times x2 of t. There's a couple of different ways you could do this, but we're going to go over it using convolution because it's helpful to keep driving this home. Um, that means that y of j omega is going to be the convolution 1 over 2 pi of x sub 1 involved with x sub 2, right? These are j omegas, of course, but I just left them out. So we can look at what the convolution will look like, and like I said, these are just two arbitrary signals. So let's take this one. So if we convolve it, and we'd flip it, so then we'd be over here, and then we have to start passing it through. So before omega equals 0, then we have no signal, and then as omega equals 0 and starts increasing, we have a signal. So now we're at omega equals 500, and now we're at omega equals 1000, and now we're at omega equals 1500, and then after omega equals 1500, we go back to 0, right? So let's get that off the screen. So that tells us that y of j omega is equal to 0 when omega is greater than 1500, right? And what this means is that the w or omega sub m of y of j omega, the maximum frequency content of y of j omega is equal to 1500, and this should have been a pi. Excuse me, that should have been a pi right there. Now, we already wrote this up here. So what is the Nyquist rate of the signal? Well, the Nyquist rate, omega sub ni, is equal to 2 omega m, which we just found omega m right here. And we have 2 times 1500 pi, which is equal to 3000 pi. We double checked that on my calculator, and this right here is the answer to this problem. That's the Nyquist rate. Like I said, that was a simple and a fun one. We didn't need any information about what the signal actually could. Well, we needed a tiny bit of information, which was what's the signal band limited to, and we could have any signal, right? So we could have any random signal that goes like this all the way over. But if we want a band limited to, we're gonna say, well, anything on this side, this is all noise. We can just band limit it to here, put a low pass filter on there, keep this, and then, well, this is our maximum frequency content of this signal because this is the stuff we care about. Anything on this side is noise. Um, but that's where all the fun stuff in this class is going. So I'm gonna call it a night for tonight. Tomorrow we get a couple more to do. We get Laplace transforms, Z transforms, which I'm not joking. I have a good time doing. So I look forward to it, and I'll see you guys then.